By 2026, the search ecosystem is controlled by generative models. AI overviews now appear in over 60% of all searches, driving a massive drop in standard organic click-through rates. To secure a citation in these overviews, a business must satisfy the algorithm's demand for verified spatial relevance. Legacy search algorithms relied on static data signals. They favored businesses with physical storefronts because those enterprises possessed explicit, easily verifiable geographical coordinates to anchor their position in the local map pack. Service area businesses, or SABs, traveled directly to the customer. Because they do not receive patrons at a central location, platform guidelines mandate that their public address be hidden. This creates a severe structural handicap, known as the proximity deficit. The business lacks the central map pin algorithms use to calculate local prominence. To rank against competitors who possess visible coordinates, the service area business must overcompensate. It has to generate a massive, decentralized footprint of digital trust signals that prove active, ongoing service coverage across its targeted region. Without a static physical point to lean on, the enterprise must engineer a dynamic web of geographic proof. Every digital asset must be meticulously structured to satisfy the machine learning models calculating its local authority. For years, digital marketers attempted to solve this deficit by manually injecting GPS coordinates into the EXIF metadata of image files before uploading them to a business profile. The theory assumed that embedding latitude and longitude would force the search engine to associate the image with the target neighborhood. A rigorous 10-week local ranking study isolated algorithmic reactions to geotagged imagery. The data dismantles the metadata theory entirely. Targeting secondary towns caused a measurable decrease in city queries and severe proximity cannibalization, plummeting search visibility at the actual physical address and decaying regional rankings. The structural reason for this failure is a matter of international compliance. To adhere to strict privacy frameworks like the GDPR, platforms automatically strip all EXIF metadata from user-uploaded images. The search engine simply does not read the injected coordinates. EXIF manipulation is a dead practice. Attempting to manufacture spatial relevance through invisible code actively damages core proximity visibility. With hidden metadata stripped away, modern search algorithms extract spatial truth directly from the pixels. Multimodal reasoning systems like Google's Gemini and Cloud Vision AI deploy complex neural networks to evaluate the actual visual composition of an image. These networks abandon inferential data. They analyze the holistic contextual reality within the frame, detecting prominent features and classifying the visual data into predefined entity categories housed within the knowledge graph. This makes landmark detection the ultimate verification tool. If an algorithm processes an image featuring unique topography or recognized architecture, it pulls highly confident spatial coordinates directly from its own database to verify the location. Advanced models comprehend these holistic contexts without any textual hints. They easily distinguish a generic suspension bridge from the specific structural identity of the Golden Gate Bridge, securely tethering that digital asset to exact coordinates. This visual verification extends to text through optical character recognition, or OCR. The algorithm reads municipal street signs, heavily branded fleet vehicles, and corporate park names directly from the photograph, indexing those terms against the local business entity. Uploading authentic proof-of-work photography, images containing localized landmarks and readable environmental text, provides the search engine with unforgeable, machine-verified physical presence. Visual proof alone is highly effective, but the semantic code surrounding the file provides the necessary relational context. Crawlers require strict coding syntax to triangulate the exact meaning of the media. This syntax breakdown shows the first step in that code logic, the file naming convention. Default digital camera strings must be replaced with descriptive, hyphen-separated terminology that explicitly identifies the core service category and the target microgeography. The alternative text, or alt text, follows a similar formula. It requires a highly literal description of the visual elements merged with precise geographic markers. The text must read as a natural, compliant sentence, strictly avoiding keyword stuffing. The final layer is JSON LD structured data. For a service area business, integrating the local business and image object schema types serves as the foundational bedrock of spatial signaling. While the physical address remains hidden on the public-facing profile, Injecting exact spatial coordinates and operational polygon boundaries directly into the backend schema feeds the algorithm the geographic parameters it requires. Wrapping visually verified images within this precise JSON LD architecture inextricably links the media asset to the business's defined commercial territory. Executing this verification on a generic 50-mile radius setting dilutes the entity's relevance. Broad service area settings fail to capture high-intent commercial queries, particularly within complex international economic zones. Consider the commercial corridor archetype, characterized by dense, high-yield business-to-business nodes located between major financial epicenters. Procuring contracts in these hyper-competitive environments demands specific structural targeting. This requires a hub-and-spoke web architecture. Instead of relying on a single page that lists dozens of towns, the business must construct highly specific landing pages dedicated exclusively to distinct microgeographies within the corridor. Each local spoke page is populated entirely with the visually verified, semantically wrapped photography and localized case studies native to that exact commercial node. The narrative copy on these pages is written specifically for local procurement officers. It details regional industrial challenges, provides operational distances to key highways, and references specific corporate park logistics to satisfy nuanced commercial search intent. Building a hyper-localized data architecture creates a mathematically undeniable web of geographic relevance, easily outpacing competitors who rely on lazy metro-wide positioning. To finalize the local entity and fully overcome the proximity deficit, the business must engineer aggressive review velocity. Earning fresh, continuous client feedback proves active operational capability far better than hundreds of static, historical reviews. The algorithm deploys natural language processing to read these user-generated reviews, actively extracting highly localized entity markers, such as specific business park names and detailed service types, straight from the client's text. Coupling this textual feedback with a continuous upload cadence of visually rich photography and active Q&A management fuels a massive algorithmic freshness signal. It proves the entity is highly responsive and currently active. This node-based model illustrates how the 2026 search ecosystem actually functions. Generative AI overviews do not guess, they compile their answers based on the semantic completeness of the local entity data ecosystem. The AI cross-references the visual proof, the structural backend schema, and the natural language text extracted from reviews. When that multi-layered data matrix aligns perfectly, the model confidently cites the business as the definitive local authority, even without a physical map pin. Local search dominance relies entirely on verifiable spatial reality. By architecting an uncompromising, visually verified, and semantically flawless data ecosystem, a service area business secures its position at the top of the generative search landscape.